Alright, so today we're going to go ahead and finish up section 6.6 and 6.7. And we had started some of this in class today, so I'm going to go ahead and take you back to, if you know the magnitude and the direction, you can find the vector. Whoops, that should be D. Using the formula, the vector is equal to the magnitude of V cosine theta I plus the magnitude of the vector sine theta J. And so we had gotten to example 2 in class, or we at least started it. The wind is blowing at 20 miles per hour in the direction north 30 degrees west. So I need you to be able to find me two things. I need you to be able to find the magnitude, and I need the direction, which is really going to be your theta. Alright, the magnitude is the easiest thing to find. That's the speed. Okay, so the magnitude is 20. Theta is a little bit harder to find, so let's go ahead and sketch what this triangle looks like, or what this wind looks like. Alright, so the wind is blowing north 30 degrees west. So my question is, what kind of angle is that? Well, we read beginning at 0, correct? So we go 0, 90, 180, 270. So my question is, how many degrees is this? Well, this is 90 plus another 30, which means theta is 150. So now I'm ready to go ahead and plug into that formula, that my vector is the magnitude of cosine theta I plus the magnitude sine theta j. Alright, well we said we know our magnitude is 20, cosine of 150, 20, sine of 150. Well, you say, well, wait a minute, 150, that's not one of my angles, or is it? So how do you find out what a 150 degree angle really is? Shouldn't I do 180 minus 150 and find out that it's really a 30 degree angle? So now look at your little table. I want a 30 degree angle. I need cosine. But be careful. In the second quadrant, cosine is negative. Okay? Hang on a minute, guys. 90 and 30 is not 150. So let me fix myself right here. 90 and 30 is 120. There, let's fix this. So really we're looking at a 60 degree angle. Thank you. That should be 120, 120. Alright, so a 60 degree angle. I know that, again, cosine in the second quadrant is still negative. So I'm going to put negative 1/2 I plus 20. Now in the second quadrant, sine is positive, square root of 3 over 2j. Now let's just clean it up. So I get negative 10I plus 10 square roots of 3j. And that would be my vector V. Helps if I can do basic math, right? Alright. The next one I want to do with you is out of the textbook. Alright, and I'm just going to go ahead and write it here. So let's see. Example 3. The jet stream is blowing at 60 miles per hour in the direction north 45 degrees east. Express this as a vector. Alright, so the jet stream is blowing. So again, I need my magnitude and I need my theta. To get theta, I'm going to have to draw a picture of what that wind looks like. So it is blowing 60 miles per hour. What does the 60 represent? That represents your magnitude. Theta is north 45 degrees east. And what's nice is I now know that this is in quadrant 1, which means everybody is positive. But I need to ask myself, this is the angle I'm finding here. So in this case, it's also 45, not because of him. Okay, so theta is 45 degrees. Now we're ready to go ahead and plug into our formula. Alright, so I know my new vector is equal to 60 cosine 45i plus 60 sine 45j. And now we do know the cosine of a 45 degree angle is, use your green sheets and you should see that it's square root of 2 over 2. And sine is also square root of 2 over 2. And now we just go ahead and clean it up. And I get 30 square roots of 2i and 30 square roots of 2j. And that's my vector for that wind. So, when you add vectors or multiply a scalar by a vector, so when you add vectors or multiply a vector by a scalar, you get a vector. So this is what we were doing today in class. If you add vector v plus vector u, you get a vector. The dot product is going to allow us to get rid of a vector. And again, the dot product is on your little green sheet right here, v dot w. Now this is not v times w, it's v dot w. And it says a1, a2 plus b1 times b2. Alright, so I'm just going to write that down again just so I have it in my notes. a1, if I have vector v defined as something I plus something j, and I have vector w defined as something I, something j, I can take their dot product, and when I take v dot w, I don't get a vector. I actually get a number. To be a1 times a2 plus b1 times b2. So when you take a dot product like that, you get a real number. Alright, let's go to example 4 then. If v is 7i minus 4j, and W is 2I minus J. Find. Let's just make a comma. Alright, first thing I want you to find is V dot W. So my formula is right here. A sub 1 times A sub 2 plus B sub 1, B sub 2. This is A1, this is A2. So it will be 7 times 2 plus negative 4 times negative 1. So I get 14 plus 4, and I get 18. So my question is dot product commutative? Let's see about that. What if I asked you to take V dot W? Are they going to give me the same answer? Alright, well let's see. So this time I'm going to multiply A1, so W becomes A1 and A2. So A1, A2 plus B1, B2. So now it's going to be 2 times 7 plus negative 1 times negative 4. And what we find out is, yes, they are. I get 18 again. Alright, what if I ask you to do W dot W? So again, it's A1, A2 plus B1, B2. So my A1 is 2 times, and since I'm dotting the W and W, my numbers are the same. Negative 1 times negative 1. So I get 4 plus 1 is 5. So the beautiful thing about a dot product is it actually will give me a number, no longer a vector. Alright, a couple more things we're going to do. We're going to talk about how to find the angle between two vectors. How to find the angle between two vectors. Again, if you look at your green sheet, there it is. So it's going to be the cosine of theta is V dot W over the magnitude of V times the magnitude of W. Alright, example 5. Find the angle between each vector. Round to the nearest tenth. Alright, let's say I have vector V is 4I minus 3J, and vector W is I plus 2J. Now, this is going to be a little bit more work. You're going to need to find me a whole lot of information. Alright, so let's get started. The first thing we need to do is I need to find the dot product. So, step 1, find the dot product of V dot W. Alright, so I'm going to multiply my A's and my B's. So A1 is 4, A2 is 1, V1 is negative 3, V2 is 2. So I get 4 minus 6 is negative 2. Alright, so that's step 1. Step 2, I need the, sorry you can't see it, I need the magnitude of V. This is what we did yesterday. If you get confused, grab your green sheet. It tells you to find the magnitude. You take the square root of a squared plus b squared. So I need the square root of a squared, 4 squared, plus b squared, negative 3 squared. So I have the square root of 16 plus 9, square root of 25, which is 5. Okay? I also need for the formula the magnitude of w. So again, I take his a squared and his b squared. So 1 squared plus 2 squared is the square root of 1 plus 4, or the square root of 5. Alright, so I have all my pieces parts. Now I'm ready to put them together and show you what this is going to look like. So I know to get theta, the cosine of theta is v dot w over the magnitude of v and the magnitude of w. So let's fill in what we know. We know that the cosine of theta, my v dot w was negative 2. My magnitude of v is 5. My magnitude of w is the square root of 5. Okay? So to get theta, do you agree that I want to take the inverse cosine of negative 2 over 5 square root of 5? So grab your calculator. Mine is buried somewhere. Okay, so I went ahead and hit second cosine, negative 2 divided by 5 square root of 5. That's what I typed in, the inverse cosine, negative 2 divided by 5 square roots of 5, and I get that my angle is 153, is that what it wanted me to round to? Round to the nearest tenth, so 153.4 degrees. So theta is 153.4 degrees. Alright, the last thing I want to do with you tonight is ask you if vectors are orthogonal. Okay? Two vectors are orthogonal in other words, the angle between them is 90. If and only if v dot w equals 0. Okay? So to tell if two vectors are orthogonal, you take the dot product and see if you get 0. Okay? And this is where we'll go ahead and wrap up. Okay? So we're at example 6. Are the vectors orthogonal? Okay, let's say I have 2i plus 3j, and w is 6i minus 4j. So all you're going to do is a dot product and see if you get 0. So v dot w. So I'm going to do 2 times 6 plus 3 times negative 4. I get 12 minus 12 is 0. So I say yes. Alright, and that will conclude it. I've got one more thing to do tomorrow in class, which is to talk about how you find work. And that'll be it. So don't forget to do a couple of practice problems, and I'll see you tomorrow.